This is my intermediate algebra course. Today we're going to continue to learn the exponent rules. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In the previous classes, we learned how to do problems that each required 1, 2, 3, and 4 rules. And we could go on to 5 rule problems and then 6 rule problems and so on. But instead, we're just going to pull out all the stops and do problems where we're not even going to count the number of rules. And I want you to understand that some of these problems, like the problem down here, are it's going to seem like they're taking a long time to finish, and you might get a little discouraged and think, these problems are just too long and tedious. But be aware that when you go into upper math courses, you're not going to have to show every step. The only reason these problems take a long time is because we're showing every step and writing the rule for each step. This problem only takes maybe about 20 seconds if you know what you're doing. But in this course, we need to show every step so that you know exactly what's going on. And, if you skip steps, then that can really spell disaster when it comes to your understanding. You need to know exactly what's happening on every step and learn how to use the rules properly. Then, when you go into upper math courses, you can, skip, sometimes, like I said, 4 or 5 steps because you can do them in your head. Another important thing that I want to bring up is that for these types of problems, there are many different pathways that you can take. So you might choose a different pathway than I choose. That's okay, as long as you get the same answer. You can be confident that you use the operations correctly and the rules correctly. I'm sorry it keeps jumping up over to the left. Sometimes this program does that. I'm not sure why. Now I forgot to show you the exponent rules. So go ahead and take a screenshot of these if you don't want to access your files from the previous classes. It's really best to take a picture with your phone because I want you to have these rules in front of you as you're doing the problems today. So let's get started with problem number 1. We're going to combine the y's. Remember, we can combine y's when you're multiplying, but not x's with y's. We can't do that. And we're also going to combine these x's. And we're going to do that before we worry about these outer powers here. So we're going to use rule number 1. And we get y to the 2 plus 3 power. And we get x to the 4 plus negative 6 power. And be aware that you don't have to write 4 plus negative 6 like so. I mean, you could just write 4 minus 6. That'd be a lot easier. But I'm just demonstrating that we're using rule number 1 where we add the exponents. So when you're doing problems that are this complicated, it's important to go back and check after you finish every step. Because if you make a mistake or accidentally omit something, then you're going to have to do a lot of work to go back and fix it. So now we're going to simplify. Now that we've checked everything, 4 plus negative 6 is negative 2. And now it looks like we're going to need rule number 3. Why? Because we have a product of a bunch of numbers raised to a power. Same thing here. We have a product raised to a power. And rule number 2, as I may have mentioned in previous classes, rule number 2 only talks about 2 terms in the product, but it works for 3, 4, infinite, or not infinite, but a lot of, as many terms as you want. So we're going to raise 2 to the 1/2 power, multiply that by x to the 4th raised to the 1/2, and then multiply that by y to the 5th raised to the 1/2. Again, that's rule number 3. Then we have negative 5 to the 3rd power, and it's very important that you use parentheses around the negative 5 because that negative is there. If the negative were not here in blue, then you wouldn't have to use parentheses. Turns out it's not going to affect the answer for this particular problem because it's an odd exponent, but you still need to write parentheses or else it's not a correct statement. Okay, so let's go back and check all our answers. Make sure that we wrote everything correctly, and it looks like everything is correct. So now we're going to use rule number 9 because we have 2 to the 1/2 power, you see. So that becomes square root of 2. So that's rule number 9. And we have powers raised to other powers, so we're going to have to multiply the exponents. That's rule number 5. And we can go ahead and raise -5 to the 3rd power. That's just going to be -125. And you want to keep the parentheses because we want to show that we're multiplying all these terms together. So we used rule number 5, and I can use green to show where we used rule number 5. Okay, so now it's typical to write the integer, the whole number first, and we're going to write the root 2 last. So let's multiply x to the, we have x to the 2nd, y to the 5/2, x to the -6, y to the 3/2, and then we can write our root 2. Again, that usually goes at the very right, the roots, or else it can get kind of confusing. Okay, so again, just double checking, everything looks right. So all we did was really simplify on that step, just move things around. So now we're going to use rule number 1 because we're going to multiply powers. So we have x to the 2 plus -6 power, y to the 5/2 plus 3/2 power, and then root 2. So now we're going to simplify. So we have -125, x to the -4th, y to the 5/2 plus 3/2 is 8/2, and 8/2 is just 4. So that simplifies quite a bit there. And then we're left with -125, y to the 4th, root 2, all over x to the 4th. And we brought that power down with rule number 8 because we have a negative exponent. Remember, we're not allowed to leave negative exponents in our final answer. So I think I'll shrink this a little bit, and obviously we're going to rectangle our final answer. So I think we used 5 rules in that problem, if I counted properly, because we used rule number 1 twice. Okay, so let's go on to problem number 2. We'll try one more of these before you try one on your own. I think we're going to have to use rule number 6 because we have an a here and we want to use rule number 1, but we have to give it some sort of a power first. Again, this is something that you would never really write in upper math courses, but we're just showing, the rules that we're using. So we get -3a to the 6th, and then we're going to change that a so it has a 1 power. And we can also use rule number 1 because we're multiplying powers, so we have b to the 3/7 plus 4/7, and then we have a to the 8 raised to the 4th, and we can also use rule number 3 because we have a product raised to a power here, so we have 2 to the 2nd times b to the 2nd, and probably want to write parentheses around that. So just to be clear, rule number 3 was used here. Rule number 1 was used here, and rule number 6 was used here. Okay, so now we're going to use rule number 1 and combine those a's. And 3/7 plus 4/7 is 7/7, so that just becomes b to the 1st power. And 2 squared is 4. And again, it's probably good to keep parentheses around that. Okay, so we're just going to simplify. We get -3a to the 7th and c to the 2/5, all raised to the 2nd. And I'm going to go ahead and use rule number 6 again to just get rid of that power. We don't really have to, but I'm just going to simplify things. And 4b squared. Okay, so double checking everything here. Everything looks right. And now we have a product raised to a power here, and we also have a product raised to a power here. So that's rule number 3. So we have negative 3 to the second, a to the 7th, also raised to the second, c to the 2/5, also raised to the second. And negative 2 raised to the 4th, b to the 4th, a to the 8th raised to the 4th, and multiplying by 4b squared. So again, that was rule number 3. And now we're going to use rule number 5. First of all, negative 3 squared, that's 9. And then we're going to use rule number 5 to multiply the exponents. Negative 2 to the 4th power, that's just going to be negative, actually positive 16. And we have a to the 8 times 4 power, and we'll just rewrite that for b squared. Okay, so we end up with 9a to the 14th, c to the 4/5, 16 b to the 4th, and a to the 32nd power times 4b squared. Alright, so I'm going to combine the 16, 4, and 9. So we may need a calculator for this. Those are going to be some pretty big numbers. 9 times 16 equals, and then times 4 equals 576. So don't be afraid to use your calculator because those numbers are kind of big. And we're also going to add, we're going to multiply all the a's together, so we're going to use rule number 1. So we have a to the 14 plus 32 power. That takes care of all the a's. And then the c, I guess we can go ahead and use rule 10. I want to save as much space as I can here. So we're going to use rule 10 and go ahead and change. Remember, we're not allowed to keep our answers with fraction exponents. So we have the 5th root of c raised to the 4th power, and then we can combine the b's. We have b to the 4th, b to the 4 plus 2 power. And we need to, it's very important to look back and make sure that you combined everything correctly. I think we combined everything right. So now you might wonder, do we have to put these in this order? No, you don't. You can put them in any order you want, but just be aware that the coefficient usually comes first. That's traditional. If you put the coefficient over here, it's not going to look right. Okay, so we have 576, a to the 46th power, and usually, like I said, the roots are written at the right, so I'm going to go ahead and write that to the right there. And we have the 5th root of c, all raised to the 4th. But be aware that you can also write the 4th power on the inside also. Both answers are correct. And that should be the final answer. So again, I know that seems like a lot of work, but the good news is we're really not going to do very many of these problems. I think we have 12 problems total, and we've already done 2 of them. So let's see, that was, we used rule 10 up here and rule 1, and that's pretty much it. So that is the answer to problem number 2. Okay, so I'm going to keep those problems in the window, and I want you to try problem number 3, and when you come back, we'll do it together. All right, we're back. So, as I said, there's multiple ways to do this problem. So if you do it a slightly different way, that's okay. I'm going to use rule number 1 first to combine those a's. let's see, what else can we do? We're going to use rule number 1 to combine the b's also. So you have b to the 2/3 plus 1/3. And I guess you don't really need a dot there. You can put letters next to each other without dots. That's okay. That was kind of a messy fraction there. And let's double check everything, make sure we got everything written down correctly. Looks correct. So now let's simplify. We have 4a to the 11th power, b raised to the 2nd, 7 negative 1, b to the 1st power times a raised to the 2nd. Okay, so now we have products of numbers raised to powers. And the powers just happen to be the same in this problem. So we're going to use rule number 3. And we have 4 to the 2nd times a to the 11th raised to the 2nd times b to the 2nd times 7 negative 1 raised to the 2nd times b to the 1 raised to the 2nd times a to the 2nd. Okay, so 4 to the 2nd power, that is 16. And looks like we're going to use rule number 5. We're raising powers to other powers, so we multiply the exponents. And rule number 5 was used here, here, and here. Okay. So we have 16a to the 22nd power, b squared, 7 to the negative 2 power, b squared, a squared. So now we're going to use rule number 1 to multiply those powers. So we have a to the 22nd plus 2 power, a to the 22 plus 2 power, and b to the 2 plus 2 power. And we're going to let's see here. I guess I'm going to hold off. You could do multiple steps here, but I'm going to hold off for now. So we have 16a to the 24th power, b to the 4th power times 7 to the negative 2 power. The reason I'm holding off is because we have plenty of room, so I can, do this a little more slowly. Okay, so now we have to use rule number 8, because obviously we can't have that negative power. So we have 16a to the 24th, b to the 4th, bring it down, and we have 7 to the 2nd. And then our final answer is going to be 16a to the 24th, b to the 4th, all under 49. So if you got that answer, good job. Okay, so I guess I'll leave number 3 in the window. I want you to try number 4. Remember, there's multiple ways to do this. And when you come back, we'll do it together. All right, we're back. Let's see. So it looks like we're going to use rule number 1. The first expression there, and the first factor, we're just going to kind of leave that for now. And we can change that b to the 1st power. And we can, and before I forget, we used rule 6 there. So that's rule number 6. And we have 3a to the 2 plus negative 5 power, c to the 1/4, all raised to the 3rd power. Okay, so now, oh yeah, we used rule number 1 there. And rule number 1 was here. Okay, so now simplifying more, we have negative 4ab, a to the 3rd, b to the 1 plus 7, and 3 times a to the negative 3 power, c to the 1/4, raised to the 3rd power. So it's good to kind of go back and check make sure that we did everything correctly. Again, if you make a mistake, it's going to be a long road to fix the problem. Okay, and we used rule number 1 in green. We used rule number 1 here. So let's continue here. So we have negative 4ab, and we're going to use rule number, well, I guess we should just simplify that. And on the last term there, we're going to use rule number 3. So we have a product in pink here, and we're going to raise that to some power in blue. So that's rule number 3. So we take 3, raise it to the third power. I guess we don't need parentheses there. We can put parentheses on the outside. Then we have a to the negative third raised to the third, and c to the 1/4 raised to the third. So that was rule number 3. Okay, so now we're going to use rule number 3 again, because we have a product raised to a power in yellow. So we have a to the third raised to the 6th, b to the 8th raised to the 6th. 3 to the third power is just 27. We're going to have to keep that in parentheses because we want to show that we're multiplying. And we have powers raised to other powers, so rule 3 tells us to just multiply those exponents. So, did I say rule 3? Hopefully I said rule 5. And rule 5 tells us to multiply those exponents, so that was rule 5 in yellow. And rule 3 in blue. Okay, so now we can go ahead and take this 27 and this negative 4, and we can multiply those together. We might as well. I guess we have plenty of room, so we don't really need to do that now. And you know what, just to avoid confusion, I'm just going to keep those separate for now. I don't need to do that at this point. Using rule 5, we're raising powers to other powers, so we multiply the exponents. And here we have a to the negative 9th, c to the 3/4. So we used rule number 5. Rule number 5 here. Okay, so now we have negative 4ab, a to the 18th, b to the 48th. And you know, I'm just taking my time here. Sometimes when you run out of room, it's okay to kind of skip some steps, but in this case we don't really need to. We have plenty of room. So now we're going to combine this negative 4 with this 27. Don't be afraid to use a calculator. 4 times 27 is 108. So we get negative 108. And we can also add the a's. But now I think about it, you know, just to keep with the tradition, we probably should write a to the first. And you know what, I'm just going to go ahead and write that on the step above so we can save some space here. So I'm going to change that to a to the first and b to the first and write rule number 6. So that was rule number 6 right there. So now we can use rule number 1. And again, we got negative 108. And we have a to the 1 plus 18 plus negative 9. Now, I don't know if we've done that where we've multiplied 3 powers together all at once, but you know, it's the same. It's just rule number 1. You're just multiplying, you know, 3 powers together. And the b's, we have b to the 1 plus 48 and we have c to the 3/4. So now let's go back and make sure that we did this correctly. Everything looks right. Okay, so we use rule number 1 here and also here. Okay, so simplifying, we have -108, a to the 10th, b to the 49th, and we can also use rule number 10, and that becomes the 4th root of c, all raised to the 3rd power. And actually, I think that's it. And that rule 10 was here. Alright, so if you got that answer, good job. Okay, so now we're going to move on to problems that have fractions. And so let's get started here. We're going to use rule number 3. We're going to use a lot of rules in this first step. So we have 5 to the 2nd, x cubed to the 2nd. So that was rule number 3, because in blue here we have a product raised to a power. And let's see here, what can we do? I think we're going to have to use rule number 4. Again, there's a lot of different ways to do this, so you just got to think about it for a little bit and see what the best way is. So rule number 4 tells us when you have a fraction in yellow raised to some power in blue, you take the numerator and raise it to that power, and then you divide that by the denominator raised to that same power. And let's double check everything, make sure we did that correctly, we wrote down everything correctly. Okay, so rule number 4 was here. Alright, so now 5 squared, and it's just 25, and then we can use rule number 5, raising a power to another power. We're just going to multiply the exponents, and we're going to use rule number 3 again over here, because we have a product. 3 times y to the 7th is a product, and we're raising it to some power. And on the bottom we're going to use rule number 3 again, so we have a product, x -4 times a to the 1/7 raised to some power -3. So we take each factor in the product and raise it to that power, and then multiply the results. So that was rule number 3. Rule number 3 there. The colors aren't always going to be the same for every rule, so just be aware of that. And I think I might raise this fraction up a little bit just so it's kind of level there. Now let's go back over this, double check, make sure that we did everything correctly. And it looks correct. Alright, so let's keep going here. We have 25x to the 6th power. And you know what, it's probably good, I guess, to write a dot here. You could probably get away with not writing one, but let's go ahead and do that. So a lot of things going on here. First of all, the 3 to the -3 power, we can't really deal with that at all, until we use rule number 8. So I'm going to go ahead and use rule number 8. That 3 to the 3rd power, that's going to come down. And we're going to use rule number 5, raising powers to other powers. We have y to the 7 times -3 power, x to the -4 times -3 power, and a to the 1/7 times -3 power. again, I know that this seems like a lot of stuff to have to do here, but again, you know, when you go into upper math courses, you're not going to show all these steps. Okay, so we used rule number 5 here, here, and here, and we used rule number 8 here. So let's see what else we can do. We're just going to simplify, I guess, at this point. So we have y to the negative 21, 3 to the third power is 27, x to the positive 12, and a to the negative 3/7. So at this point, let's see here. we're going to multiply what appears to be a whole number. Now this may or may not be a whole number. We don't really know because we don't know what x is. But we're just going to consider it to be like a whole number. So when we're multiplying a whole number by a fraction, we have to write that whole number as over 1 so we know how to multiply it. And we're simultaneously going to use rule number 8. I'm going to bring the negative a power up. So we have a to the 3/7 on top. And bring the y to the negative 21 down. And the reason for that is because those have negative exponents. So I used rule 8, but I also used rule 8 prime. Okay, so double checking everything, and obviously we're out of room. That's okay. We'll go to the next page. So I'm just going to copy this up here so we can see what's going on. So now what do? Well, we can just multiply straight across. We're multiplying this fraction with this fraction. So we multiply the numerators and then multiply the denominators. It's that simple. So we end up with 25 x to the 6th, a to the 3/7 over 27 x to the 12th, y to the 21st, and remember, everything is still raised to the second power. All right, so at this point we need to combine these x's using rule number 2. So we'll go ahead and do that. So we have 25 x to the 6 minus 12 power, and I'm just going to keep that fraction power there. We could use rule number 10 at this point, but I'm just going to keep the fraction for now because we're going to multiply it by 2 anyway. And we have 27 in the denominator, and we still have y to the 21st. Okay, so just double check, make sure everything's correct. And we're going to simplify, so we have 25x to the negative 6. A to the 3/7. I don't know what my computer's doing there. It's making things disappear and then come back. Okay, 25. Again, just keep rechecking. I know it's boring to have to keep rechecking, but that's just something that you're going to have to do unless you want to have a really hard time with these problems. Now this step I just copied, so we don't really need to keep that. We can move this up. And we'll take it from there. So now we have a negative power. We can go ahead and deal with that. So we'll bring that negative exponent, the power with negative exponent, down. So now at least we don't have any more negative exponents. And that was rule number 8. So now we have a fraction that is raised to some power. So that's rule number 4. So we use rule number 4 that tells us to take the numerator and raise it to that power, and then divide that by the denominator raised to that same power. Okay, and now we're going to have to use rule number 3, because we have products raised to powers. So we're going to take the first number in the product, raise it to that power, multiply by the second number in the product, raise it to that same power. Same thing on the denominator, 27 to the second power, y to the 21st to the second power, x to the 6th to the second power. Okay, and let's see here. We might have to buy some more space. Okay, now that we have more space, I'm going to bring this down so we can see where we're picking up. 25 to the second power, that's going to be a pretty big number. 25 times 25, that's 625. And 27 to the second power, that's 729. And then we have a to the 3/7 times 2 power, that's rule number 5. Raising a power to another power, you multiply the exponents. And same thing in the denominator. Okay, so we have 625 a to the 6/7 and 729 y to the 42nd power and x to the 12th power. So at this point we're almost done. It's just we have a fraction exponent. We're not allowed to have fraction exponents. And let's see here. We have 625, and that's going to be the 7th root of a, all raised to the 6th power, over 729, y to the 42nd power, x to the 12th power. So that was rule number 10. Okay, so that was again a problem where we had to deal with fractions. So that looks correct, and let's rectangle the final answer. And I'd like you to try one of those problems. I'm going to try to keep the previous problem we just did in the window. So go ahead and try number 6, and when you come back we'll do it together. Alright, we're back. If you couldn't see that problem because we were zoomed out, you can go ahead and pause the video now and attempt it. So what should we do first here? Notice that we can't really combine anything in here. In the previous problem, we couldn't really combine anything that way either. I think we're going to use rule number 4 first, because we have a fraction raised to a power. So we're going to have b to the -1, a to the 2/3 raised to the 6th over 2 to the 2c raised to the 6th. Alright, that was rule number 4. And now we're going to use rule number 3, and that's going to be -3 to the 2nd, a to the 2nd, b to the 2nd. Okay, go back and double check everything. Everything looks right, and now it looks like we're going to use rule number 3. Move this down a little bit. So we have b to the -1 raised to the 6th, a to the 2/3 raised to the 6th. That was rule number 3. And again, we have rule number 3 again in the denominator. So those were all rule number 3's. Okay, and now negative 3 to the second power, that's just going to be 9. And so we have 9a squared b squared, and I guess we should put a dot there. We can use parentheses or a dot. I'm just going to use a dot. Continuing to simplify. Let's see, we are going to use rule number 5. Make sure these brackets are big enough they cover the whole thing. So rule number 5 tells us we're raising a power to another power. We multiply the exponents. And 2 to the 6th power, that's just going to be 64. You can do that in your calculator if you need to. 9a squared b squared. Okay, so now what do we do? I think we'll just simplify. So we get b to the negative 6, a to the 4th power over 64 c to the 6th. And I'm going to go ahead and write 9a squared b squared. I'm going to write that over 1 because we're going to multiply that into a fraction. So we need to kind of make it into a fraction. So we can see what's going on. So there's a couple different ways we could do this. Obviously, we're just going to multiply these fractions. So we're multiplying straight across in the numerator and straight across in the denominator. I think I'm going to just go ahead and do it that way with the b's. So we're going to have, we're going to use rule number 1. And so we're going to have b to the negative 6 plus 2 power, and a to the 4 plus 2 power, and I forgot to write the 9. We're just going to have the 9. Coefficients usually go on the front, remember that. It's not wrong to write them to the right, but it's really strange looking. In the bottom we have 64c to the 6th power, and that's all raised to the 3rd power. So we're out of room. That's okay. We're just going to move this up, and I'm just going to copy it so I don't have to keep looking down, but we'll erase that extra copy once we get rid of it. I think we actually wrote an extra step on the last problem. Yeah, this step here in the last problem actually wasn't, I copied that but forgot to erase it. It's not really that big of a deal, but I don't want you to think that we wrote an extra step for no reason. Okay, so, whoops, I got to bring this up here. Alright, so that's where we left off. And we have 9b to the negative 4, a to the 6th, all over 64c to the 6th, and that's all raised to the 3rd. And we don't really need brackets at this point because, you know, we don't have, you know, parentheses within other parentheses, but just to avoid confusion, I'm going to keep those brackets. And at this point we can use rule 8 to bring that b to negative 4 down. So we have 64c to the 6th, b to the 4th, and all that is still raised to the 3rd power. So now we're raising a fraction to a power, so we're going to have to use rule number 4. You take the numerator and raise it to that power, and then divide that by the denominator raised to the same power. But now we're going to have to use rule number 3 because we have products raised to power, so we have 9 to the 3rd power, a to the 6th to the 3rd power, over 64 to the third power, c to the sixth to the third power, and b to the fourth raised to the third power. So now we're going to have to use rule number 5 because we've got powers raised to other powers. And a calculator would definitely be useful here because these numbers are pretty large. So 9 to the third power, that's going to be 729. And using rule number 5, we're going to multiply the exponents when you're raising powers to other powers. 64 to the third power, that's going to be a huge number. I didn't mean to give you such a big number there, sorry about that. But we have 262,144. Again, I apologize for that huge number. C to the 6 times 3 and b to the 4 times 3. Okay, so we're almost done, so I'm just going to move these over. And I think we have plenty of room to write the final answer to the right. So our final answer is going to be 729 a to the 18th power all over 262,144 c to the 18th b to the 12th. And just be aware that you cannot combine the b's, the c's, and the a's. You can only combine a's with a's, b's with b's, and c's with c's. You can't combine a's and c's, or b's and c's, or a's and b's. So if you got that answer, good job. Okay, let's go to some more problems here. We're going to do this one together. And looks like we have fractions raised to certain powers. I notice there's a 0 power here, so we can use rule number 7. And I notice that we have x's here that we can combine. So there's a number of different things we can do. We also have negative exponents. We can get rid of those. So I'm first going to use rule number 7 though. But again, we're going to use rule number 8 to get rid of those negative exponents. And let's see, at least this negative exponent we'll get rid of. This one, these x's we can just combine. So I'm going to bring that x to -3 down. And b to the 0 power, that just becomes 1. And so in the numerator, we're just left with 3y to the 4th. And that's still all raised to the 4th power. So I want to make it clear that rule number 7, that was here. And rule number 8, that was here. And we're also going to use rule number 2 because we're dividing powers. The x is here, so we have x to the -2 minus 2, and we can probably move that 2 to the center there. Alright, let's double check everything. Everything looks right. And so rule number 2 was here. Dividing powers, we subtract the exponents. Okay, so now I think we're going to use rule number 3 because we have a fraction here raised to a power. So we're going to take the numerator and raise it to that power, and then divide by the denominator raised to that same power. And normally what I would do is I would simplify by multiplying 1 in yellow, but that's just going to be we're going to have to rewrite a lot of stuff, so I want to kind of avoid that. And then we have x to the -4 a cubed over 2, And, you know, we could use rule number 8 to get rid of the negative power, or we could just use rule number 4 and then deal with the negative power later, but I'm just going to deal with the negative power now. But in terms of rules, you know, we didn't really do much over here. We just simplified. So we really only used, in fact, you know what? I'm sorry. That's not rule number 3. That's rule number 4. Sorry if I confused you there. This here is rule number 4 that we used. Okay, so, but now we're going to use rule number 3. And again, I'm going to use rule number 8 to get rid of that negative exponent. So rule number 3 tells us that when we're raising a product to a power, we take each number in the product and raise it to that power and then multiply the result. So we have 2 to the 4th, x cubed to the 4th, a to the 5th to the 4th. Okay, so that was all rule number 3. And now we have a cubed 2x to the 4th. So I used rule number 8 to bring that power down. And so now we have, first of all, 3 to the 4th power. That's just going to be 81. And 2 to the 4th power is going to be 16. And now we have powers raised to other powers, so you know we're going to use rule 5. And let me bring this down a little bit. When you're raising powers to other powers, you use rule 5, which tells us to multiply the exponents. And we're also going to use rule 4 again on the fraction at the right. So we have the numerator raised to that power divided by the denominator raised to that same power. And you might wonder, do we need to write a multiplication symbol between here? And there's so many parentheses involved that we don't really need to. But if you want to, you can, if that helps. Alright, so we're simplifying. We have 81 y to the 16th and 16 x to the 12th, a to the 20th times a to the 3 times 5 using rule number 5 again. And so let me write that down. We're using rule 5. And in the bottom we're also going to use rule number 3 again, because we have a product raised to a power, so we take each factor in the product and raise it to that power and then multiply the results. So we used rule 5 here, and rule 4 we used here, and now we're using rule 5 here. And rule 3 we are using here. So a lot going on here. Okay, I think we have some more room down here. So I'm going to go ahead and bring this down. Okay, so now let's just simplify. We're going to rewrite this fraction. And here we get a to the 15th power. And 2 to the 5th power, that's going to be 32. And then we have rule number 5 again. So again, let's double check all that, make sure we have everything right. And since this was just a copy of the previous step, we can get rid of that and bring this up. Let's make that fraction line a little straighter. Okay, so I guess we're going to, so we had to use rule number 5 on that step, which was here. And I'm just going to rewrite, and I know it's kind of a pain to sometimes rewrite when nothing much really changes, but again, this is not something that you're going to have to do when you get into upper mathematics courses. Alright, so now we're ready to multiply those fractions. So multiplying across, we have 81 y to the 16th, a to the 15th over 16, and we're going to use rule number 1. 16 x to the 12 plus 20 power a to the 20th. And whoops, we're going to have to multiply 16 times 32, and when you do that, that's kind of a big number, so don't be afraid to use your calculator. We get 512. And so now we can use rule number 2 at the same time that we simplify. So we have a to the 15 minus 20 because we're dividing those powers. And we have x to the 32nd power. And so dividing the powers, we get this, subtracting the exponents, and then we use rule number 1 here. And then we get 81 y to the 16th, a to the negative 5, all over 512 x to the 32nd power. But we can't leave our answer with a negative exponent, so we use rule number 8 and bring that down. And we have x to the 32nd power, a to the 5th, and that is our final answer. So that's just another type of problem that you'll see. Okay, so we're going to try another one of those types of problems. I'm going to leave number 7 in the window. If you can't see number 8, then I'll zoom in later, but go ahead and try 7. When you come back, we'll do it together. Alright, we're back. If you couldn't see number 8, go ahead and pause the video now and try that problem. So there's a lot of different things we can do here. We can use rule 2 because we have these powers that are being divided. And I think we can also, I'd like to get rid of these negative exponents on the x's, so we can use rule number 8 because we're bringing the x's down. And I can also take this c to the negative 3rd power and I can bring that up to get rid of the negative exponent. So that's rule 8 prime. Okay, so let's get into it here. So we have y to the 6 minus 5 power, and the x to the 4th, I'll bring that down, and the c, like I said, we're going to bring that up. So maybe I can move the x to the 4th over to make this look more symmetric. I think that's correct. Remember, always double check. There's so much going on here, we need to double check. So then we have y cubed and a to the 5 minus negative 10. Now be aware that that's a double negative. We're going to have to deal with that. And we have 4 in the bottom, and I'm going to bring that x down, again using rule number 8. So again, after each step, go back and check, make sure that everything looks right. I think I wrote that correctly. So now, and just to be clear, rule number 2 was here and here, and rule number 8 was here and also here, and rule number 8 prime was here. So if there's any doubt whatsoever, that's what's happening. So now we have 4 y to the 1st power, c to the 3rd over x to the 4th, all raised to the 2nd power. And we have have y to the third a to the 15th power all over 4x squared raised to the third. So all we did at that point is just simplify things. So go back and check, make sure everything's correct. And now it looks like we're going to be using rule number 4. We're going to take the numerator, and actually I can use rule number 6 also. I'm going to use rule number 6 first. We're going to change that y to the 1 power to just y. We don't really have to, but I might as well. So 4y c to the third power raised to the second, all over x to the fourth raised to the second. And over here we're going to use rule number 4 also, because we have fractions raised to powers. Okay, so you know, if you want to, you can put a dot in between here showing that we're multiplying. You don't really have to, but if that helps, you can do that. Now we're going to use rule number 3, and I can see we're going to use rule number 5 also. So we have 4 to the second, y to the second, c cubed to the second. And here we're going to use rule number 5. When you raise a power to another power, you multiply the exponents. You know, y cubed to the third, a to the 15th, raised to the third, all over 4 cubed, x squared cubed. So rule number 3 was all this stuff here. Okay, so constantly going back and double checking, making sure that everything's correct. It's so easy to make a mistake on these problems. So now 4 to the second power, that is 16. And we have c to the 3 times 2 power over x to the 8. And y to the 3 times 3 using rule number 5. So on and so forth. 4 to the third power, that's going to be 64. And x to the 2 times 3 power. So we used rule number 5. And I think we just simplified everything else. Okay, so let's take this and bring it up so we can start on the next page. So let's simplify. We have 16 y to the second, c to the 6th, over x to the 8, times y to the 9th, a to the 45th, 64x to the 6th. Okay, now we can get rid of this stuff here, because that was just a copy of the previous step to save room. And now looks like we're going to have to use rule number 1. We're just multiplying fractions, so you just multiply the numerator straight across, multiply the denominator straight across. So we have 16 y to the 2 plus 9 power, c to the 6th, a to the 45th, all over 64 x to the 8 plus 6 power. And let's see here. So now we have 16 y to the 11th, c to the 6th, a to the 45th power, over 64 x to the 14th. By the way, rule number 1 was here and here. I don't think you need me to show you that, but just to be clear. Alright, so actually I think that is the final answer. It looks like that is, actually no, that's not the final answer, I'm sorry. We can actually reduce 16 over 64. If you left it in this form, that's okay. That's a correct answer, but 16 over 64 can actually be reduced. So I didn't have a problem where you could reduce the fraction previous to this, so I didn't mean to trick you, but 16 actually goes into itself, obviously, and it goes into 64 also. So divide both sides by 16. And 16 divided by 16 is 1, and 64 divided by 16 is 4. And there you go. So that's the final answer. So if you got that answer, good job. Okay, on to the next problem. Now for this problem, it's important to understand that with this factor over here, you can combine the a's and b's in the top with the a's and the b's in the bottom before you deal with this exponent. But with this problem, with this factor over here, you cannot combine the a's and the b's in the top with the a's and the b's in the bottom before you deal with these powers, because these b's are raised to the -1 power, b's and a's, and these b's and a's are raised to the 3rd power. You see, so there it's a separate exponent for the numerator and denominator. So let's get started. I think here we can use rule number 3. Because we have a product raised to some power. And on the bottom, same thing. And now, like I said, we can combine this inner part before we deal with the 3 power, and we're going to use rule number 2 for that. So I'm going to move this over. By the way, this here was rule 3. And so we have a to the 2 minus -8 power times b to the 4 minus 2 power. And the 4 stays down. And then we have, what else can we do? Well, I see an a to the 0 power. You see that? That a to the 0 power, so that means we can use rule number 7. So that becomes 1. I'm going to be sure and color that before I forget. And by the way, this is rule number 2 over here. We can also use rule number 8 to bring this a to the -2 down. You see that? So I'm going to bring that down. That's rule number 8. And we can bring this b to -5 power, we can bring that up using rule 8 prime. So bringing that up, and that's all raised to the 4th power. So again, it's good to go back and double check everything. I think everything's right. Okay, so now we're going to use rule number 5 because we have powers raised to other powers in blue. So we have a to the 3 times -1, and so on and so forth. 3 cubed is 27. And we have a to the 10th, b to the 2nd, and simplifying, we just get b to the, well, I guess I can go ahead and use rule number 4 there. I don't think you really need me to simplify that. Obviously, a squared times 1 is a squared. So we used rule number 5, and we also used rule number 4. So let me color these. Rule number 5 and rule number 4. Okay. Okay, so again, you just want to keep going back and double checking, make sure everything's correct. And everything does look correct. So let's continue to simplify here. We get a to the negative 3, b to the negative 4, 27b to the 6th, a to the 21st power. And here we're going to use rule number 4. Okay, so now we're going to use rule number 5 over here. Now we're going to use rule number 8 because we have these negative powers, so we can, actually no, we can just use rule number 2 to combine those. So rule number 2, we're dividing powers, so we have a to the negative 3 minus 21, b to the negative 4 minus 6, all over 27. And using rule 3, and then 4 to the 3rd power is 64. Alright, and then divided by b to the 20th over a to the 8th. Continue to simplify, and we get a to the negative 24, b to the negative 10, all over 27, times 5 cubed, which is 125. Then we're going to use rule number 5, raising a power to another power. And you know, we can go ahead and change this. We know we're going to divide, so we can just flip that, change to multiplication. Alright, so now we're going to copy this and bring it down. So now we're going to use rule number 8 because we have all these negative exponents. So we're going to bring those down, and there's not going to be anything left on the top. So we have to write a 1. And simplifying, and we're getting pretty close to the end here. The rest is going to be fairly easy, but let's just make sure we know what rule number 8 was. That was here. So now we're just going to multiply straight across. We're multiplying fractions. You just multiply the denominators and the numerators. So multiplying the numerators, 1 times all this, and a to the 8th, we're going to use rule number 1. So 125, a to the 30 plus 8 power, and then b to the 6th. And then down below we're going to have to use the calculator because it's kind of a big number. 27 times 64 is 1,728. And we have a to the 24th, b to the 10 plus 20. So that was rule number 1. Now we're going to use rule number 2. So we have 125, a to the 38, b to the 6th, over, let's see, we have b to the 30th. So we just simplified there. Actually, now that I think about it, we're not using rule 2 yet. We're just simplifying. Now we're going to use rule number 2, and this should be our final answer. So we have 125. Actually, it's not going to be our final. 38 minus 24, b to the 6 minus 30, all over 1,728. So we end up with 125, a to the 14th power, b to the negative 24th power, all over 1,728. And actually I forgot to erase this stuff because that's just a copy of the previous step, so I can move that up. So our final answer is down here, and again we used rule number 8 to move that b down. Alright, so there you go. That's just another type of problem you're going to have to deal with. Okay, so I want you to try a problem like that, but before you attempt this, let's go over a few important things. Remember the order of operations agreement, which we can recall using this acronym, parentheses, exponents, multiplication, division, addition, subtraction. We learned that order of operations agreement in my arithmetic course. And the agreement, notice these arrows, the agreement tells us that when you have only multiplication and division, you want to move left to right. That's what the arrows tell us. If you move right to left, you'll get a different answer, the wrong answer. It's agreed that you need to move left to right. And let me explain, let me give an example. So let's say you have 6 divided by 2 times 3. If you do the division first, moving left to right, which is the correct way, then 6 divided by 2 is 3, and then 3 times 3 is 9. But if you do it the incorrect way, if you go right to left, multiply first, then you'll get 6 divided by 6, which is 1. These are different answers. So, they can't both be correct. Well, it turns out this one's correct just because mathematicians have agreed that when you see this notation, it means move left to right. Now, I want you to be aware that I didn't talk about that in the previous problem, because in the previous problem, it just so happened that it didn't really make a difference. It didn't really affect anything. Okay, because the division sign was on the right, whereas the multiplication was on the left. But in this problem, it's actually going to affect something. If you multiply these first, then you're going to get the wrong answer. Because if you multiply these first, then you have to take that result and divide it into this expression here. That's going to be wrong. So what do? You flip this first using the division operation and change this to multiplication. Then you can deal with the problem. So flip this fraction first and change this to multiplication. That means you're dividing this fraction by this fraction first, then you can multiply the result by this fraction, and that's going to give you the right answer. Another important thing that we went over in the previous problem is, notice that this whole fraction is raised to the third power. That means you can combine the numerator factors with the denominator factors first, before you deal with the third power. But over here, that's not the case, because the numerator is raised to the second power, whereas the denominator is raised to the third power. So you have to raise all these to the second power individually, then raise all these to the third power. Then you can combine the numerator factors and the denominator factors. But you cannot combine them before you deal with that second power and third power. So just be aware of that. Go ahead and try number 10, and I'm going to try to leave number 9 in the window. And when you come back, we'll do it together. All right, we're back. So let's see here. What can we do? I see we have a 0 power in the denominator. I'm going to use rule number 2 first, because we're going to combine. So we have x to the 3 minus 8, c to the negative 4 minus negative 3, and be aware that's a double negative. And, whoops, that's not correct. It's c to the negative 4 minus 2. I confused that b there. And then the y to the 0, that just becomes 1. And we can also take that b to the negative 3 power and bring it up using rule 8 prime. So, looks good to me. We just need to raise it to the third power. Don't forget to do that. And now over here we're going to use rule 3, because we have products raised to powers. So we have y to the second raised to the second, c to the fourth raised to the second, x raised to the second, c to the third raised to the third. I didn't really see that 0 power, but I'm going to go ahead and color that blue because that's also rule 7. And that would be raised to the third power. So I kind of jumped forward a little bit there. Hopefully I didn't confuse you. And then times b squared over x to the 4th. Alright, let's go back and double check this, make sure that everything's correct. Everything looks right. And by the way, rule 3, we'll color that purple. So this is all rule 3 down here. Technically everything was rule 3. Let's simplify. We have x to the negative 5, c to the negative 6, b to the 3rd. And, you know, we don't really need this 1 down here. You know, if you divide by 1, it doesn't really do anything. So we can kind of just get rid of that. Probably going to have to make it a fraction again, but alright, now we're raising powers to other powers. So that's rule number 5. We multiply the exponents in that situation. So we have y to the 2 times 2, c to the 4 times 2, and c to the 3 times 3. 1 to the 3rd power is just 1. We have y to the 5 times 3 times b squared x to the 4th. Okay, so double checking everything. Everything looks right. And so now we can use rule number 3 because we have a product here. You see in red, we have a product here raised to a power. So we have x to the negative 5 raised to the 3rd, c to the negative 6 raised to the 3rd, so on and so forth. And dividing by y to the 4th, c to the 8th, x squared over c to the 9th, y to the 15th. So now what can we do? Well, actually we're going to use rule number 5, so raising powers to other powers, using rule 5 again. And I'm going to go ahead and write this over 1 because it looks like we're going to need a fraction to understand this division. And actually, before I flip this, we're going to use rule number 2. I'm going to write rule number 2 over here. And so we have y to the 4 minus 15, c to the 8 minus 9, and x squared. And let me move this over a little bit. And times b squared over x to the 4th. Okay, so let's simplify. We have x to the negative 15, c to the negative 18, b to the 9th, all over 1, divided by y to the negative 11, c to the negative 1, x squared, and that's all multiplied into b to the 2nd over x to the 4th. And if we want to, we could take that green and write it under 1. In fact, I don't really need the under 1 at the yellow, on the yellow term at this point. So I'm just going to copy this, bring it to the next page. So what I'm going to do is I'm going to just write all this over 1. And because we're dividing, let me write that symbol a little better. Because we're dividing, remember when you divide fractions, and we have to do this part first before we multiply, or else we'll get the wrong answer. So we're going to change this to multiplication and then flip the divisor. And over here we can just keep everything. And the reason I'm not getting rid of the negative powers over here or over here is because we're just going to combine these anyway. And we can deal with any negative powers we come up with at that point. So Now we're just multiplying fractions, so we can just multiply straight across with the numerators, and we get x to the negative 15th, c to the negative 18th, and b to the 9 plus 2. We used rule number 1 there. And on the bottom, multiplying the denominators, we get y to the negative 11th, c to the negative 1, x to the 2 plus 4. So again, we used rule number 1 down here. All right, so let's double check, make sure that's all correct. It looks right. So now we're going to use rule number 2. Dividing powers, we just subtract the exponents. And y to the, actually I guess we're not going to do much with y. And we're not going to do much with b either. So that should be correct. Again, we'll just double check. Yep, that looks right. We're going to get x to the negative 21 power, and c to the negative 17th power, and b to the 11th, and we have y to the negative 11. So now we just have to get rid of these negative exponents. So we're going to use rule number 8 to bring the negative exponent, negative powers down, and rule 8 prime to bring the negative powers up. So we have b to the 11th, y to the 11th, over x to the 21, c to the 17, and that should be your final answer. So we used rule 8 here, and we used rule 8 prime here. Okay, so if you got that answer, good job. Okay, let's take screenshots of all the work that we did today to help you with your homework or to study for tests. Here's screenshot number 1 and screenshot number 2 and number 3 and number 4 and number 5 and number 6 and number 7 and number 8 and number 9. But don't go before you get your homework. Let's take a look at the homework. So here's the homework. Get a screenshot of the first 2 pages. And take a screenshot of the answers. And before you go, I want to mention a few things. Notice that there's only 10 problems. In class, it felt like the problems were taking a long time. So I'm only giving you 10 because these problems are a little bit involved. But be aware that they don't really take that long. Again, as I mentioned at the beginning of the class, they don't really take that long. It just seems that they're taking that long because you have to show every step. Also, notice in red it says because there are different ways to do each of these problems, I'm not going to list the rules along with the answers. So notice that there's no list of Roman numerals showing you which rules to use, because you can use the steps in different orders. So it's not going to be helpful for me to list the rules and the answers. And to be honest with you, in this particular homework assignment, I don't really care if you show the rules for each step. Even though I told you to show the rule numbers, the Roman numeral of the rules, the exponent rules for each step in the directions here, I don't really care if you do that for this particular homework assignment, because it's just going to be too tedious to have to write those rules for each step. You're going to be doing plenty of work just to to show the step itself, but you do have to show the work. I'm not saying skip steps. You do have to show the work. I just don't really care for this particular homework assignment if you show the Roman numeral of the rules. But be aware that that's not true in previous classes. In previous classes, I want you to show the Roman numeral for each rule that you use. But when you get to these types of problems where you're having to do 5, 6, 7, 8, 9, 10 steps, sometimes 20 steps that require a Roman numeral for each step, I'm not going to require you to do that. But again, be aware that that's only for this class. For the previous classes, I want you to show the rules that you're using for each step. Also, I've said it before, I'll say it again. If you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. And remember, your homework has to have 4 characteristics. It has to be correct, complete, neat, and in chronological order in your binder. So get that homework done, and I'll look forward to seeing you in the next class.